Okay, solving. So, first and foremost, here we want to keep in mind SOHCAHTOA, because that's going to be your guideline. So, anytime you go to solve a right triangle, what that means is you're going to find all the missing pieces. They'll give you a certain amount of information. An angle and a side is usually enough, or a couple sides is enough. And from that information, you should be able to find all the other missing angles, like angle M here, or side N, or side P. Now, finding the other angle in this case, that's straightforward, because if you know one angle, you know the other one's got to be its complement. So we would simply take 90 degrees minus the 43.6 and get, let's see, that would be 46.4, I believe. Yeah. So that would be a 46.4 degree angle. Now, the sides, I would recommend using this angle. In fact, I'm going to assume we're going to use this angle. And from that angle, we have this side as the opposite. This is the hypotenuse. That makes this the adjacent. So the key here is I have the adjacent. So I have the adjacent, and let's say I'm going to go find this side. This is the opposite. So if I said adjacent and opposite, so the one I have and the one I'm looking for, which of these would make the most sense to use? Which one of those lists adjacent and opposite? And that would be this one, because these two use the hypotenuse. So the tangent is the one I want to use. Tangent of the angle, 43.6, is going to equal the opposite, which is n, over the adjacent, which is the 124. And then we simply solve that. And this is going to be a continuing thing. We've picked the right trig function, set this up, and basically you're going to be missing one of three things, either the angle or a side or one of these two sides. If you have this situation, just multiply both sides by 124. And we'll get our answer from there. So we'll have 124 times 43.6 tangent, then equals, and that's going to be 118. So n is 118. Now, meters, we'll say. I could use the 118 and the 124 to find the hypotenuse using Pythagorean theorem. My only suggestion is that you might want to not do that, because if we made a mistake with this, we would perpetuate that mistake. So instead, and it's also good practice to do it, let's say I want to use the adjacent to find the hypotenuse. Well, if I have adjacent and hypotenuse, that's cosine. So I would write cosine of the 43.6 degrees is equal to the adjacent, 124, over the hypotenuse, which is p. Now, when you're trying to find the variable is down here, let me give you a little hint. What we do is we multiply both sides by p, and at the same time, divide both sides by the cosine of 43.6, which just puts that over here at the bottom. But the truth is, but what really that boils down to is it's perfectly legal to switch these two. So we'd end up with p equals 124 divided by the cosine of 43.6. And then we would do that. So 124 divided by cosine of 43.6, cosine equals 171.2. So p is 171-ish, 171.2 meters. So that's p, n, and the missing angle we did early on. Same deal. All right, we're going to just practice. This is just a chance to kind of work ahead of me, maybe. Practice, see how you're doing. Check to see what your answer is. You know, fast forward to the video or something to see what the answer is. But here I have 77.9, 40.3, I don't know C, and I don't know either angle. Okay, so we can attack C first. That's the hypotenuse. So we can use Pythagorean theorem in this case to start with. C is going to be the square root of a squared plus b squared, which means C is going to be the square root of 77.9 squared plus 40.3 squared. So 77.9 squared plus 40.3 squared equals, and then take the square root, 87.7. So C is 87.7. What do we have? Yards. All right. Now, the angles, let's use this and this. If we're going to find angle A, go in alphabetical order, opposite would be that side. Hypotenuse, of course, for both of them is this. That means this is the adjacent side for angle A. So if I use A, let's use opposite and adjacent. So that would be tangent. All right, then go through SOHCAHTOA. Opposite and adjacent is tangent. So the tangent of angle A is the opposite, 77.9, divided by the adjacent, which is 40.3. So I'll do the 77.9 divided by 40.3. So 77.9 divided by 40.3. I get 1.933, we'll say. So the tangent of angle A is 1.933. Well, if I want to find angle A, that means I'm going to take the inverse tangent of 1.933. So when we're looking for the angle, when the angle is the thing we don't know, that's when we use the inverse tangent. So I go to my calculator. Since that number is already on the screen, I'll just hit inverse tangent, and that's 62.6. So A is 62.6 degrees. And I'm pretty confident with that, so I'm going to take a chance here and just subtract this 62.6 from 90 degrees in order to find B. So that's going to be 27.4, I believe. So angle B is going to be 27.4 degrees. And we already found side C, that was the 87.7 yards. And there's our 3 missing items. Alright, solve the right triangle with, let's see, so I got a 71, so I have angle B, angle A, angle C is the right angle. Side B is 120 inches. And angle B is 71 degrees. So I know angle A, for example, is 29 degrees. And let's see, I got side C and side A are the two other things I need to find. Let's go after C. Now we're going to go after the hypotenuse. I'm going to use the 71 degree angle. You could use either. I'm going to use the 71. Opposite is 120, so that's what I have, and what I'm looking for is the hypotenuse. So opposite and hypotenuse. Which trig function is it? Think. That's right, it's the sine. So the sine of our 71 degree angle is equal to the opposite, 120, over the hypotenuse, which is the C I'm looking for. Remember, we can just switch these two. It's perfectly legal algebraically. 120 divided by sine of 71. So 126.9 sounds good to me. Now we'll go for side A. Still going to use this angle, still going to use the 120, so that's opposite still. And now I'm looking for adjacent, so that's going to be tangent. Opposite and adjacent is tangent. So the tangent of 71 degrees is opposite, which is 120, over adjacent, which is A. So A is equal to 120 divided by the tangent of 71 degrees. 41.3. Remember, the smallest angle should always be across from the smallest side. So 41.3 makes sense for the smallest side. The next biggest angle, the next biggest side, and the 90-degree angle should be across from the largest side, which is the 126. Makes sense. So then they'll give you just every problem from here on out is going to be a way of giving you a right triangle. So here's a right triangle. And looks like they give me the hypotenuse and this angle. And I believe they're looking for this, which is the opposite. So I'm looking for the opposite. I have the hypotenuse. That's going to be opposite hypotenuse. That's sine. So I got the sine of a 35. Okay, let's just take care of this right now. So 29 divided by 60. Because it's in minutes, and we don't want minutes, divided by 60, that's to be 0.483. So this is really a 35.483 degree angle. That'll work. Equals opposite, which is D, over the hypotenuse, which is 13.5. Multiply both sides by 13.5. And I'll be in business. So I got 13.5, whoops, times the sine of 35.483 sine equals 7.84. So that distance is 7.84 meters. All right, so this problem, I'm going to redraw this picture so it's a little clearer. All right, ultimately, what they want, I believe, is the total height of the building across the street. We'll call that H. Now, I have a couple right triangles here. I have 53 degrees is this angle. I have 19 degrees is this one. This distance here is the 35 feet above street level, because this window, your viewing point, if here's street level, that's your height. That's also this height from a spot directly across from you. So I'm going to use this bottom triangle. I'll make it red just to highlight it. So I want to make this bottom red triangle, which is a right triangle, assuming the buildings are all not the Leaning Tower of Pisa. And I'm going to find this side right here. Because if I find that, that's the connection between this red triangle and the one above it. So this is hypotenuse for that red triangle. This is the opposite, as long as we're considering this angle. And this would be the adjacent. So I know that the adjacent and opposite. So I need the tangent of that 19-degree angle is equal to 35, the opposite side, over the adjacent. I'm just going to call that, I call it A. That's fine. That means A is going to be 35 divided by the tangent of 19 degrees. So 35 divided by tangent of 19 degrees is 101.6. So A is 101.6. Is that feet? Yeah. So I know this is 101.6. Now, I have the, let's see, for the upper triangle, we'll put it in green. This triangle. The hypotenuse is here, this is the opposite, and this is the adjacent. So I have the adjacent, and I'm looking for the opposite, because once I know this, I can just add it to the 35, and I'm in business. So, let's see, opposite and adjacent again, it's tangent again. So the tangent of the 53-degree angle is equal to the opposite side. I'll just call it P, over the adjacent, which is the 101.6. So 101.6 times the tangent of 53 will give me P. So 101.6 times 53 tangent equals 134.8. So P is 134.8. And then my final answer is for the total height, remember I want this whole distance, is going to be 35 plus 134.8. So that's going to be 169.8 feet. All right, so they give us the shadow length, they give us this and this angle, and find the height of the tower. So this is our hypotenuse, definitely. If we're dealing with this angle, this is the adjacent side, and this is the opposite side. I'll call this y, that variable y. So if I'm trying to find y, then I've got opposite and adjacent. That I'm trying to find opposite. I have adjacent side, so that's tangent. So the tangent of a 29-degree angle is equal to y over 77. 77 times the tangent of the 29-degree angle. $42.7. So y is 42.7 feet. All right, so we have company safety committee recommended find the angle of depression of the light to the nearest one. So the angle of depression is this right here, which, by the way, since the horizontal here is parallel to the ground, is also this angle here. So if you were here looking down at this corner of the building, it'd be the same angle looking down as if you were here looking up at the top of the lamppost. Makes sense. So I'm looking for this angle. I have an opposite side and I have an adjacent. So it's tangent again. But this time I don't know the angle. The tangent of the missing angle is going to be the opposite, 39 point... Is that a number? 05. There we go. Divided by the adjacent, which is 51.6. And so I find that number first. 39 divided by 51.6 equals. So I have 0.7568, 0.7568 roughly is equal to the tangent of theta. Remember, if we're missing the angle, what's the next step? To find the angle, we do the inverse tangent of that number. Now that number is already sitting up in my calculator, so all I have to do is hit inverse tangent, and I'm there. 37.1. All right, you're headed towards a plateau that is 59 meters high, so somehow you know the height of the plateau. Don't ask me how. And the angle of elevation to the top of the plateau, so from wherever you are, there's your car, wherever you are to the top of the plateau. So somehow you know the angle, and you know the height of the plateau. And they want to know the distance, we'll call it x, you are from the plateau. So opposite, adjacent, tangent. So the tangent is going to be 40 degrees is going to be the opposite, which is 59 meters, over our distance x. That means x is going to be equal to 59 divided by the tangent of 40, because we can switch those two. That's going to be 70.3. So x, you are going to be 70.3 meters away from the plateau. Or feet, meters? I think it's meters, yeah. All right. So I got a face carved on the side of the mountain. There's your face. So, you're down here. It's an enormous mountain. That's all right. We're good. Getting a little goofy here at the end. So, you're at this point. You are 850 feet from the base of the mountain. So, we take two angles of elevation. One of them is from here to the bottom of the face, and that's a 32-degree angle. So could we find this distance here? Sure, we'll call it height 1. So that represents, for the 32-degree angle, that's the opposite side. And we have the adjacent. So once again, tangent comes up. So tangent of 32 degrees equals opposite, which is h1, over 850. So h1 comes out to be 850 times the tangent of 32. So it's going to be 531.1. All right. So we just keep that in the back of our head, because then we're going to go to this triangle. From the same spot, we measure to the top of the face, and we build this triangle. Now, we still have the same 850, but this angle is now 35 degrees. And so it's the same problem, except now H2 is what we're actually going to find. So once again, tangent comes into play. The tangent of a 35-degree angle is equal to h2 over 850. That means h2 is going to be 850 times the tangent of 35. So 850 times 35 tangent equals 595.2. 595.2. Now, they want how tall the face is. But a quick inspection will make you realize that that's just going to be h2 minus h1. So it's going to be 595.2 minus 531.1. So minus 531.1. So 64.1, we'll say. So the height of the face is 64.1 meters. Feet. Sorry, physics teacher used to working in meters all the time. Okay, so this is a little strange, but they do a series of questions in here in this section about bearings. So on a compass, 0 degrees is due north. So as opposed to when we work on the coordinate system, 0 degrees is, I guess you call it east or whatever, it's this way. So, but on a compass, this is 0 degrees. And then it gets even funkier, because on a compass, this way is positive. So in other words, this would be 90, this would be positive 180, this would be 270. And so when you say 270 in a bearing, you're headed west. Well, contrast that. in a math type system, this is 0 degrees, and not only that, you rotate the other way for positive. So 90, 180, and 270 would be that way. So for this problem, we're not using the mathy way of doing things. We're actually using this. So initially, they're going in a bearing. So this is due north. They're 30 degrees east of that. And then they turn to 120 degrees to the east, or to rotating to the right of north. Well, the key there is this. 120 minus 30 is 90 degrees, and that's this angle. So this is a fancy way of saying this is a right angle. So I have this right triangle. You'll believe it's a right triangle even if it doesn't look that way, right? All right, good. I fixed it up a little bit. Okay. Now, what about the distances? Well, this is enough information to get me this distance right here. Because if I travel at 150 miles an hour, let's say I just went for 1 hour, well then I would go 150 miles, right? So we just multiply these two to get the distance. So this distance here is going to be 1.2 times 150 miles per hour. This distance here is going to be 2.1 hours at the same speed. So times 150. So I got 1.2 times 150 is 180. So this side is 180. And the other side's 2.1 times 150. That's 315. Now I don't know, this is where he starts, this is where he ends. This is the hypotenuse, right? Opposite the 90-degree angle. So how far is the plane from the starting point? So that's what they want. They want this distance right here. Well, truth is I don't know any trig functions here because I can use Pythagorean theorem. I can say that 180 squared plus 315 squared, take the square root of it, and that'll give me that h, that distance I'm looking for. So 180, so 315 squared, boom, plus 180 squared equals, and then I take the square root, 362.8. So this distance would be 362.8 miles. So this problem, I'm going to skip over this one. It's not worth the time and effort to go over right now. All right, good. Now wrap us up right now. I will post this one at a later time for my 181 class. If you're doing this as part of my AP Physics summer assignment, don't worry about this one.